Hello, this video is for Algebra 1, Chapter 1, Lesson 7 and 8. Lessons 7 and 8. We're going to talk about the distributive property and different ways it can be used, as well as some really fundamental properties of numbers. So we do have a lot to talk about, so I'll get started. Though it's easy stuff, so don't let the a lot scare you. Alright, so the distributive property can make mental math go easier. So make sure that you're on board with that. So the distributive property, let's say we have 21 times 101. Now this is something I do not want to take my time to just multiply out, but I can do this a little quicker if I break the 100 up, because I'm breaking the 100 up because it's really easy to multiply things by 100. And also, because I'm breaking up the 100, I still need to multiply by 101, but I can do it in a very interesting way. I can break it up into 100 plus 1. Do you agree that 100 plus 1 is 101? Good, because we're still multiplying by 101. We're just kind of breaking it up a little. So if I go ahead and distribute, it would basically be 21 times 100 plus 21 times 1. Well, 21 times 100 is 2,100, and 21 times 1 is 21. So 2,100 plus 21 is 2,121. Isn't that so much easier than just doing some crazy math? Yeah, use the distributive property for mental math, guys. It will really super help you, especially on standardized tests, especially when you're taking a timed test. If you get really good at this will be quicker than using your calculator. Promise you. But you have to get good at it. So don't be like, Miss TH, I tried it and I'm like super slow. Well, you have to practice, okay? Gotta practice. All right, so here's another example. And as you notice, on this one we added. All right, well, here's an example of where we can subtract. 98, super close to 100. Super close, right? And it's basically like 100 minus 2. And again, multiplying by 100, super easy. So I'm going to break 98 into 100, which is 100 minus 2. 100 minus 2 is 98, got it? All right, now distribute. 24 times 100 is 2,400. 24 times 2 is 48, and now I just have 2,400 minus 48, which is 2,352. So much quicker, and you guys can do it. It's super easy. And honestly, I'd rather subtract than do some crazy multiplication personally. And just remember that this works really well for decimals. So here's a decimal example. We have 5.98 times 6. Well, 5.98 is really close to 6. So close that if we only subtract 0.02, we're going to have the answer we started with. So 6 minus 0.02 is 5.98. So we're still multiplying by 5.98, but in a slightly different form. Distribute. 6 times 6 is 36. 6 times 0.02 is 0.12. Go ahead and subtract, because honestly I would rather subtract than multiply whenever possible. And I'm going to get 53.88. All said and done. All right. Now let's talk about distributive property with variables and the distributive property and multiplying by -1. So here we have some variables, and we're going to distribute the thing outside of the parentheses to the things inside the parentheses. So it's going to be 2 times 5x plus 2 times 3. Actually, I'm going to go ahead and write that real quick down here, even though I don't show it, because this technically should be review. All right, so that's the 2 times 5x plus 2 times 3, okay? And you're going to get 6x, because 2 times 5 times x is 10x, right? 2 times 5 times x is 10x, and you guys all know 2 times 3 is 6. All right, so next up, we're multiplying by a negative. Basically, how you would read number 5 is the opposite of the quantity 2x plus 1. So we're going to distribute that negative sign. Let me actually show that distribution. We're going to distribute that negative sign to everything that's going on. So it's going to be the opposite of 2x plus the opposite of 1. Well, the opposite of 2x is negative 2x, and the opposite of 1 is 1, and you just got to add. Okay, last example problem for this. Ooh, I wrote over myself. Give me a second. Let me fix that. Oops. No, okay. I can fix this. I swear I can. Let me get rid of that. Okay, there we go. Fixed. Well, that's a -1. where the arrow is. You can figure it out. Okay, so number 6 is the quantity 3 minus 8a times negative 1. So I'm going to distribute the negative 1. The only thing is I highly recommend, remember from the last lesson, that you add the opposite. Whenever you got a subtraction problem, add the opposite, because it's going to make your life easier and you're going to have to do less bookkeeping, things that are just tedious in math. That's what I call bookkeeping later, and you're not going to forget about things. So we're going to add the opposite, and it's going to be 3 plus negative 8, because you add the opposite, and you multiply everything by negative 1. So it's going to be 3 times negative 1, which is negative 3, plus negative 1 times negative 8a is positive 8a, because you're basically taking the opposite of a negative. The opposite of a negative is a positive. All right, moving on. Oh, boxes, whatever. All right, so terms. Terms are anything basically that's separated by an addition sign or a subtraction sign. And I didn't write that, so I'm going to go ahead and write that. Give me a second. Oh, look at that. It's like magic. It's called pausing, doing something, and starting the recording again. Okay, so term is anything separated by addition or subtraction. All right, and the coefficient is basically when you have a term that has a variable and a number is being multiplied by it. So in this case, oops, hold on. Okay. So in this case, there you go. The 6, the 5, and the 3 are all coefficients. And actually, just to make it clear, it's actually a negative 5 that's the coefficient, because I had to add the opposite, right? All right. So a coefficient is the numerical factor. Numerical means number. Factor means multiplied by. So we're multiplying, in this case, the 6 times a squared. So the coefficient is the 6 because it's the numerical thing that's being multiplied. Okay? All right. The constant of it is a term without a variable. So that's the constant, right? Yeah. There's the constant right there, 12. Or negative 12, add the opposite. Don't forget that, all right? So the only constant in here is 12 because it doesn't have a variable attached to it. And then like terms are things that have the same variable factor. And variable factor actually has to do with the exact same letter and the exact same exponent. So make sure you pay attention to that. So in this case, here's a list of some like terms, 3x and 2x. The numerical factor, also known as the coefficient, can be different, but the letter has to be exactly the same. And the letter also has to have the exact same exponent. So 9x squared is not a like term with 2x because they don't have the exponent in common. So they have to have the letter and they have to have the exponent. It has to be the same letters too. So up here actually, let me use a different color. Up here, there are actually no like terms because none of them have the exact same letter in common and none of them have the exact same exponent in common. So there's actually no like terms in the example in the green bubbles. Whereas these list of like terms in red, you know, those are like terms, those are like terms. You get the idea. All right, next up. So let's combine like terms. Combining like terms means to simplify them. You're putting them together. And you can add terms, and you basically just add them by the number. So if I've got negative 5c's, and I add 1c, because there is an invisible 1 right there. It's really hard to see. That's a 1. The invisible 1 right there. Negative 5 plus 1 is negative 4, so I actually have negative 4c. The next example, I have negative 9w to the third and minus 3w to the third. And they are the same, they are like terms because they have the w to the third. Hold on one second, I need a cough. Hold on. All right, I'm back. Okay, and again, the terms are the same because they have the same variable and the exponent. So add the opposite. And it's negative 9 plus, so negative 9 plus negative 3 is negative 12, and we're going to end up with negative 12w to the third. And I did it yellow and green. All right, next up, some properties. These properties are important because they justify why you show your work. If you're showing your work, you're showing these properties in action, all right? So commutative property of addition and multiplication means that you can rearrange numbers. So see here how there's the 3, the 7, and the 4, and then here it's the 4, the 7, and the 3. I can do that because I'm adding every time in this equation, or in this example. As long as I'm just adding, I can move it around. Or I can move things around if I'm just multiplying. So in this case, the 4, the 3, the 7, I could rearrange it as 7, the 4, and the 3. So that's the commutative property. And think commute, you're commuting in traffic, right? When your parents are driving around and they're stuck in traffic, they're commuting. So commuting means to move location. All right, associative property. Oh, too much. The associative property shows that you can move parentheses. So notice here that the 3, the 4, and the 7 aren't moving order. The only thing that's moving is the parentheses. And that can happen when you're just adding or just multiplying. Okay? So here, again, the 3, the 4, and the 7 haven't moved location. The only thing that moved is the parentheses. All right, this is going long, and I'm sorry, I'll try to speed up. Okay, the identity property of addition just means whenever you add 0, nothing changes. The identity of multiplication means whenever you multiply by 1, nothing changes. That's why they're identity, nothing changes. You're still you. Well, when you add 0, you're still just you, just like 4. 4 is still 4 when you add 0. Nothing's changed. It's still you, still has its identity. And the same with multiplying by 1. 4 is still itself even though you've multiplied by 1. All right, last slide, and I didn't even bother because it's a lot of weird, crazy stuff. So let me powerhouse right through it real quick. All right, inverse property of addition. When you add the inverse, you get 0. This is from the last video. So if you're having trouble with this, go back and watch the video for, I believe it was 1.5 and chapter 1, lesson 5, and chapter 1, lesson 6. So if you're having trouble with that, go back and watch that video. All right, the inverse property of multiplication we haven't talked about yet. It's when you multiply by the reciprocal of something. The reciprocal of A is 1/8, 1 over A. So when you multiply A times its reciprocal, you're always going to get 1. And that's because if you write A as a fraction, it's going to be A over 1, right here, A over 1, A over 1. Well, A over 1 times 1 over A, A times 1 is A, 1 times A is A over A is 1. So the inverse property of multiplication says anything times its reciprocal is 1. All right, property of symmetry. If A equals B, then B equals A, which means whenever I see A, I can replace it with B, or whenever I see B, I can replace it with A, because they're equal. They're interchangeable. It's like getting a substitute teacher that would be like my clone, but not exactly. Anyway, bad example, moving on. Multiplication property of 0, multiply anything times 0, your answer is 0. Multiplication property of -1, multiply anything by -1 and you get its opposite. The opposite of 2 is -2, and basically that's all mathematically done by multiplying by -1. All right, last up, deductive reasoning, the process of reasoning logically that gives facts to a conclusion. Basically, whenever you have to prove the steps of a problem you're showing, you're using the property to describe each step. All right, I'm done. Happy Friday, because I'm recording this on Friday. If you're not watching it on Friday, I'm sorry, but have a good weekend because I'm recording this on Friday. Bye. Sorry it was so long. Bye, bye, bye.